Hello, so we are going to learn about fractional distillation. We just watched a video on simple distillation. So what's the difference between fractional distillation and simple distillation? So in fractional distillation, we are actually separating a mixture of two liquids, and these two liquids can mix. We call it miscible. So the word miscible is a new word. It's two liquids that can mix or dissolve in one another, and these two liquids must have a different boiling point. So as long as they can completely mix together, they're called miscible. And some examples would be like ethanol, water, air, right? It's not really a liquid, but gases, they're mixed together, and crude oil. So like petrol, kerosene, when they mix all together, they are all miscible liquids. Right? So that's why fractional distillation can actually be used to separate crude oil. So we can separate petrol from kerosene or diesel from petrol, right? So this is an application of fractional distillation in crude oil. We can separate the different components of air from liquid air, nitrogen, oxygen, argon. And also we can separate the ethanol when we do fermentation to get our alcoholic drinks. So when we compare simple distillation and fractional distillation, there's a few things that we must notice, right? So in fractional distillation, you will notice that there is this fractionating column. I think it's important for you to take note of this. It's called the fractionating column. And the fractionating column is to actually create a larger surface area for condensation to occur. This ensures that the liquids get separated better. Okay, so it's increased surface area. So what does it mean? So a miscible liquid is, for example, like ethanol and water. Ethanol has a boiling point of 78 degrees Celsius and water has 100. So it's rather close, not like the salt and water example that we saw. So that's why we need to use the fractionating column, right? And distillation is also the process of boiling and condensation. So let's take a look. So firstly, as usual, ethanol has a lower boiling point, so it will boil first, and the ethanol and the water vapor will rise up. Okay, so both will rise up. However, the water vapor has a higher boiling point, so it will condense first in the fractionating column, and then the water vapor will fall back down while the ethanol continues going up. So the ethanol, which has a lower boiling point, reaches the upper part first, and then it will distill over. And then the ethanol will collect first, and the thermometer will show 78 degrees Celsius, which is actually the boiling point of the first distillate, ethanol. And then the ethanol will cool down, and the ethanol will be collected, distillate in the receiver, and only after all the ethanol has distilled over, then the temperature will continue rising to 100. And then once it reaches the boiling point of water, it will be collected as the distillate now. So how does the graph look like? Okay, so the graph looks like that. So first the liquid, the thermometer measures until it reaches 78, and once it reaches 78, which is the boiling point of ethanol, ethanol will start distilling. So that's why it remains constant, right? Only after all the ethanol has boiled over, then it will start increasing to 100, and that's when the water will start to boil and it will distill. So the volume of the distillate only starts increasing when the ethanol starts increasing first, and then ethanol is collected as the first distillate. Right? The volume of the round bottom flask, at the start we have ethanol and water here. Then when it starts boiling, the ethanol goes over, but then at the end water is left at the round bottom flask. So over here, when ethanol finish collecting and there's only water left, then we can quickly shift and change the collecting flask so that the ethanol and the water at the distillate side doesn't mix. So we're going to just switch it out, put another conical flask to collect the next distillate. So the next distillate is water. So over here, only until we reach the boiling point of water, which is over here, right? The water will start collecting, which is the second distillate. So we can imagine the volume of the round bottom flask firstly will decrease because of ethanol. After that, it will decrease because of the water. So let's look at this question over here. So this is fractional or is this fractional or simple distillation? So you're right, this is simple distillation because there's no fractionating column. So inside here there's aqueous calcium chloride. Aqueous means solution with water. Okay, aqueous means solution with water. Now, so that means over here are calcium chloride and water, and then so therefore the first thing that comes out over here would be water. So when water is being collected, the thermometer will show the temperature of the boiling point, and then the distillation flask will left only calcium chloride. All the water has gone over, so I've left a white residue. Okay, let's look at the next question. So over here, this fractionating, fractional distillation. So fractional distillation, there's ethanol in water. So what's happening here is that the ethanol and water is mixed, it will go up, and then they want to ask you what's the change in concentration in flask F as distillation proceed. So as distillation proceed, the ethanol is being distilled over, meaning the amount of ethanol decreases and decreases and decreases, right? So we cannot have B because B remains the same, cannot be C because C increases, and D cannot be because it goes down only a bit and then it suddenly goes up again. So the answer is A because starting there's a lot of ethanol in the water, but slowly the ethanol gets distilled over and then all the ethanol distills over. That's why the concentration of ethanol decreases down to 0. Okay, so this is fractional distillation, and I hope this helps you understand it better. Right? All the best.